So we've talked to quite a few people in the last few months who study things that change in the night sky, things that go bump in the night, and which come from things like exploding stars, stars that are crashing into each other, or stuff falling into black holes.
Yeah, but those are kind of things that we know about. There's plenty of times that stuff goes bump in the night or there's a new spot in the sky, and we don't have a great explanation. They're there for a night and they might disappear that same night or on seconds or week timescales. And yeah, those tend to be pretty mysterious sometimes.
And one such mysterious phenomenon was first discovered not all that long ago, fast radio bursts, or FRBs. And we continued talking to Brian Metzger from the last episode about these FRBs. So welcome back, Brian.
Glad to be back. I still have about a half a bottle of wine.
All right, so can you tell us just a quick little history and what are these FRBs, these fast radio bursts?
Yeah, so fast radio bursts, they're fast because they typically last less than a millisecond. They're radio bursts because they come out in radio bands and yeah, so one of the so they were first discovered in 2007 by Duncan Lorimer. There was a very bright burst, and one of the ways we do see bursts that come from radio pulsars in our galaxy, and based on the arrival time of the burst at different frequencies, we can learn something about how far away it's coming from in our galaxy. But the interesting thing about this fast radio burst was that that distance was much further than coming from our galaxy. So it seemed like it possibly could be coming from outside of our galaxy. There wasn't anything then seen for a while. So actually, for several years, people thought that weren't even sure if they should believe this phenomena as being real. Could it be some kind of terrestrial interference? In fact, there was a class of bursts that were discovered that aren't FRBs but are related, called peritons, that were ultimately found to be associated with someone prematurely opening a microwave oven at parks. People had reason to be skeptical. But since that time, they found that these things are real. They do seem to come from far away, but we don't know a whole lot else about them.
So you said they were first discovered in 2007. Why did it take that long? Why hadn't they been seen before?
That would be a great question for a radio observer, but I think it's because they are fairly rare. They are short.
All right, so you may not be on the observation side, you're on the theory side. So what's the theory behind them? What do you think these things are?
Okay, well, I should just say that there have been, dozens of proposed models. Probably, it's like the early days of gamma ray bursts. There have been more proposed models than there are bursts, and probably more than there are theorists, which means we each have more than one. I think we've conclusively now ruled out there were some ideas that maybe they do come from the galaxy, but for some reason they're confusing us. They just appear to come from further away. I think those are mostly ruled out now. They do come from other galaxies. So interestingly, one of the issues with identifying these sources is they're hard to pinpoint on the sky to localize very accurately. And so for all of the FRBs, except for one, they don't know the position on the sky accurate enough to say which galaxy it came from. So the real breakthrough was a few years ago when, in my opinion, there have been many breakthroughs, but one of the major ones was using the Very Large Array to precisely localize one of the fast radio bursts. And in particular, it was the fast radio burst that doesn't seem to burst just once, it actually repeats many times. And so there's this one fast radio burst which they've identified the galaxy it comes from. And one of the early clues was this wasn't any ordinary galaxy. It wasn't like the Milky Way. It was a tiny little dwarf galaxy. Most of the stars in the universe are not in these little galaxies. Most of the star formation is not in these little galaxies. But one thing that does happen in these little galaxies are rare explosions. For instance, long gamma ray bursts and very powerful supernova we call superluminous supernova. And so to me, that was a big clue as to their origin. I I personally think that they come from very active, uh, highly magnetized neutron stars that are formed in supernova explosions, so-called magnetars. And they go through a very hyperactive phase in the first decades of their life, which causes them to burst periodically and create these bursts.
So you mentioned there are like a dozen models. Do any of these models involve aliens?
I think Avi Loeb at Harvard had a model where they involved aliens turning on some kind of thruster. I don't remember the nature of this, but there are alien models. And so, you'd have to postulate that all aliens across the universe have the same thrusters, I guess. Uh, so yes, there have been models proposed. Last resort, as usual. Maybe, yeah, the aliens apparently like to live in dwarf galaxies for some reason.
So what's gonna push this forward? Trying to figure out the theory behind them. Is it just trying to localize more of them and see if they do continually? Do we continue to find them in these little dwarfy galaxies?
Yeah, I think what we need, I think it's the same approach that we took to gamma ray bursts, where you had the BATSI mission, which didn't localize any of them very well, but got a huge sample and told us, okay, they're isotropic on the sky. This is their luminosity distribution. And then having a smaller sample, we are able to localize sufficiently well to pinpoint what kind of galaxies. So I think we're going to learn a lot from that. The other interesting thing is that this bursting source, at the position of the bursting source, is a synchrotron nebula. So in addition to, sorry, I don't know what synchrotron radiation is, I'm sorry, but it's radio emission that's produced by electrons gyrating in a very strong magnetic field. And there's a cloud of this magnetic gas surrounding the site from where the fast radio bursts are coming out. It could be that is a nucleus of a galaxy. There could be a region surrounding a supermassive black hole. Or it could be the birth nebula of one of these magnetars. So in addition to this flaring magnetar, we're actually seeing the magnetized gas surrounding it, embedded inside this young explosion. So our best estimate is that the repeater was formed in a supernova that happened about 30 years ago. And so we're making predictions for how that nebula should evolve, how its properties should change in the next few years if it really is from one of these explosions. So getting more of these will obviously help. We don't know if all the fast radio bursts repeat or whether there's different classes, ones that just go off once and then another class that repeats. So that's another thing that only a large sample will tell us.
Well, great. You make a compelling list of potential observations that you've seen that kind of jive with some ideas you guys have had. And we'll see where this goes in the future, but definitely a pretty new field and a growing field. So thanks again for chatting with us, Brian. Appreciate it.
Cheers.